This shows what happens when untreated water hits a pristine microporous membrane. Watch how dark particulate matter immediately chokes and seals those tiny pores. Industrial reverse osmosis, or RO, membranes are extremely sensitive. Even microscopic suspended solids and slight variations in turbidity will completely shut them down. When pretreatment fails, the result is rapid membrane fouling. That translates to millions in replacement costs and catastrophic plant downtime that stops production entirely. The entire financial viability of a multi-million-dollar RO system relies completely on the operational success of the unassuming, low-tech pressure filters sitting right in front of it. But choosing the right protection means navigating an alphabet soup of acronyms. Filters like MMF, AGF, MGF, DMF, and PAF. This diagram illustrates the core mechanical trade-off operators must evaluate. You have to choose between a filter that relies heavily on surface-level capture or one that uses multi-layered depth filtration inside this pretreatment clock. Make the wrong choice and you either burn through your capital budget on an over-engineered system or you underprotect your expensive downstream equipment and destroy it. There is no single universal filter. Success requires analyzing the physical properties of the filter media and matching them directly to your facility's specific particulate load. Let's start with the baseline, the auto-valved gravity filter, or AGF. In industrial setups, this is a pressure filter that utilizes exactly one type of media, quartz sand. Look at this cross-section. As the water flows downward, the uniform sand grains rely on physical straining. Notice how all the suspended particles get trapped in a dense, choked layer right at the top of the sand bed. The AGF is highly cost-effective and robust, but because dirt accumulates on the surface, it has a very low dirt-holding capacity and demands frequent backwashing to clear the clogs. To solve that rapid surface clogging, you can upgrade to a multi-grade filter, or MGF. This cross-section shows the MGF. Instead of uniform sand, it uses progressive sizing, coarse grains at the top, fine sand at the bottom. As water trickles through, each depth level captures smaller impurities, pulling the workload deep into the filter bed. The MGF maximizes the depth of the sand to extend runtimes. But because it relies on a single material type, it lacks the diverse density properties required to protect highly sensitive RO systems. That brings us to the dual media filter, or DMF, which layers two entirely different chemical media inside a single vessel. This diagram shows the standard DMF setup, a lightweight top layer of jagged anthracite coal resting over a bottom layer of heavy, dense sand. The division of labor is highly efficient. Large void spaces in the anthracite catch bulk solids, preserving the dense sand matrix below. During backwash, water flow reverses upward. The lighter anthracite expands and floats, while heavier sand sinks, perfectly restratifying the layers. A DMF balances high filtration efficiency with excellent operational reliability. This is why it serves as the most common gatekeeper deployed right before RO units. If you need to push efficiency to the absolute limit, the multimedia filter, or MMF, adds a third high-density layer, typically garnet, to the bottom. In this cross-section, descending density filtration functions across the bed, anthracite on top, quartz sand in the middle, and fine garnet at the base. As water passes downward, progressively smaller particles are trapped at each transition, resulting in zero particles escaping the bottom output. But this comes with a steep trade-off. An MMF requires the highest upfront capital cost and highly precise, complex backwash controls to manage three entirely different material densities without permanently mixing them. That operational complexity is justified only for facilities demanding maximum runtimes and ultra-low silt density index outputs to protect delicate downstream processes. There is one major exception to the multi-layer trend, the pressure anthracite filter, or PAF, which uses an exclusive packed bed of crushed anthracite. Unlike smooth sand, anthracite particles are angular and lightweight, creating massive empty spaces between the media. As heavy organics and oil flow in, they adhere to the rough coal edges. These large void spaces absorb heavy solids without abrupt pressure spikes. Engineers deploy PAF systems specifically to prevent system choking in heavy effluent treatment plants, handling high turbidity water and heavy organic loads. Evaluate your feed water condition against downstream sensitivity through 3 challenge paths. Focused purely on removing primary suspended solids, route straight to an AGF or MGF system to save on capital costs. Managing organically heavy, high turbidity water, route directly to a PAF system, avoiding rapid pressure drop failures. If your downstream equipment is rugged, investing in complex multimedia systems is simply an unnecessary waste of your operational budget. Now, let's look at the final, most critical branch. Providing pretreatment for highly sensitive reverse osmosis plants forces a split choice between DMF and MMF. Deciding between a dual media and multimedia filter comes down to a strict ROI calculation. You have to weigh your upfront capital budget against exactly how strict your silt density index requirements are. Accepting those higher upfront costs and managing complex fluidization backwashes serves as a direct insurance policy, keeping your expensive RO membranes intact. Achieving a positive ROI in filtration depends on matching the media's physical dirt-holding capacity to the specific vulnerability of your downstream membranes.